In this video, we're going to be discussing the concept of the mole, as well as molar applications and stoichiometry, which you will understand by the end of this video. The scale of atoms isn't something we can easily work with in chemistry, so to simplify calculations, we can use a measurement called the mole. The mole represents a number, just like how a dozen represents the number 12, and a century represents 100. Likewise, a mole represents a number as well, this number being 6.022 times 10 to the 23rd. Now, moles are used within atoms, ions, molecules, substances, or just any chemical species we use in chemistry. And a mole is also the same as Avogadro's constant. So, in textbooks and exam questions, a mole can also be referred to as Avogadro's constant or Avogadro's number. They can be used interchangeably. So what this means is that everyday amounts can be described in atomic scale units, allowing us to apply these small atomic sizes into everyday applications like chemical equations, calculations, and experiments. Before we start with chemical conversions, it is best we understand what molar mass is and how to use it. Molar mass is the mass of an element, substance or compound, or just any species, but for exactly 1 mole. For example, carbon has a molar mass of 12.011 grams per mole. So this is the molar mass of carbon, and the molar mass can be found on the periodic table. Now, you might be asking what the difference between molar mass and mass is. So let's say in a substance we had C2, or 2 carbon. The molar mass changes based on how many atoms of that element you have. So let's say we had 2 carbon. The molar mass actually changes and becomes 2. So we do 12.011, which is the mass, times 2, because we have 2 carbon, giving us roughly 24.2 grams per moles. However, the mass actually stays the same. So that's the difference between molar mass and mass. So the mass actually stays the same, but the molar mass takes into account the amount of atoms you have of each element. So in chemistry, we can convert between mass, moles, and atoms. To convert from mass into moles, we divide mass by the molar mass, which we talked about above. And to go from moles into atoms, we times by Avogadro's constant, which is 6.022 times 10 to the 23rd, or we times by a mole. Now, likewise, we go from atoms into moles. You should be able to do this. We just divide by the same number, 6.022 times 10 to the 23rd. It's very essential that you memorize this number as it is used in lots of chemistry. And to go from moles back into mass, we just multiply by the molar mass. Now, we can put this into practice. If we calculate the amount of atoms in 3 moles of a substance, let's calculate the amount of atoms in 3 moles of a substance. We know, starting off, that 1 mole is equal to 6.022 times 10 to the 23rd. So 3 moles is 6.022 times 10 to the 23rd times 3. Remember, to go from moles into atoms, we times by Avogadro's constant. So it is 6.022 times 3 for 3 moles, which gives us, putting this into our calculator, it gives us 1.81 times 10 to the 24th of atoms. Don't forget to write atoms. Likewise, dividing the number of atoms gives us the number of moles. And for example, let's calculate the moles of a molecule with 1.2 times 10 to the 25 atoms. So like we mentioned, dividing the amount of atoms by Avogadro's constant, which is 6.022 times 10 to the 23rd, is how you calculate the amount of moles. Rounding, this gives us to 20 moles of this substance. Now, if you want to find the molar mass of a compound, the first thing to do is to find the overall molar mass, or the molar mass of each individual element, and then add them up. So let's take an example. Let's take C₃H₆O as an example. So if we look at the periodic table, carbon has a molar mass, like we mentioned above, of 12.011 grams per mole. And hydrogen has a molar mass of 1.0078 grams per mole. And oxygen has a molar mass of 15.999 grams per mole. Now notice that this isn't done because, remember, in molar mass, we have to take into account all the atoms of this substance. We have 3 carbon, which means the molar mass will need to be timesing by 3 in order to get the molar mass. So timesing carbon by 3 gives us 36.033 grams per mole. Likewise, timesing hydrogen by 6, because we have 6 hydrogen, gives us 6.0468 grams per mole. And oxygen, we can just leave the same because we only have 1 of oxygen. So the overall molar mass is now, we have all the information to work out the overall molar mass. We just need to add the terms of each element. So let's add them. 36.3 plus 6.0468 plus 15.999. This gives us the overall molar mass of this compound, which adds up to, putting this in our calculator, to be precise, 58.088 grams per mole, which is the molar mass. Just remember to not forget any units, as you may lose marks in exams, and also being precise in your measurements or your units in grams or anything in chemistry is very good, as being a few decimal places off can definitely get you the wrong answer in a multiple choice exam. Now, with this information being the molar mass, we can calculate how many moles of this compound we have. Feel free, guys, to pause the video and write down your answers based on the conversions we mentioned above. Now, in order to convert mass into moles, we need to divide the mass by the molar mass we have just found. So the mass, remember, is just the mass of each element, disregarding the amount of them. So carbon being 12.011 grams per mole plus hydrogen being 1.0078 grams per mole, and oxygen being 15.999 grams per mole, which gives us, adding them up, 29.0178 grams per mole as the mass. Now, to get from moles, remember, we need to do the mass divided by our molar mass. So let's put this. So we get 29, which is our mass, 29.0178 divided by 58.0788. So that is the mass over the molar mass, giving us the moles. So putting this into our calculator gives us 0.499 moles, or rounding, just giving us 0.5 moles. Now, that is the answer for this question. Don't forget to, please don't forget to leave out units, as well. Thank you guys all for watching the video. If you have any further questions or would like some more practice questions integrated into the video, drop a comment below and don't forget to like and subscribe. Feel free to let me know if this video helped you out, and I'll see you guys next time. Goodbye.